Hello and welcome to my channel. In this video, we are going to solve a question from Quadratics chapter, which had appeared in Cambridge 9709 Pure Mathematics 1, variant 1 to February-March 2025. A curve has equation y is equal to 5 plus 3x minus 2x square, and a straight line has equation y is equal to kx plus 13, where k is a constant. Find the set of values of k for which the curve and the line do not meet. So here we have been given an equation of curve and equation of a straight line, and it is given that we have to find out the set of values of k for which the curve and the line do not meet or do not intersect. So let us begin by substituting the equation of line, that is y is equal to kx plus 13, in the equation of curve. So the equation of curve, that is 5 plus 3x minus 2x square, is equal to, now y is being replaced by kx plus 13. Now let us take the left hand side terms on the right hand side, because we are trying to get the x square term as a positive term. So minus 2x square goes on the other side and becomes plus 2x square, plus 3x on the other side becomes minus 3x, and plus 5 becomes minus 5, and these two terms stay the same. So we get plus kx plus 13 equal to 0. Now here we can see that minus 3x and plus kx are like terms. So rearranging this, we have written 2x square plus k minus 3. Now we have taken x as a common factor out from these two terms. So the second term becomes plus k minus 3 in the bracket times x. And finally, minus 5 plus 13 gives us plus 8 equal to 0. Now since it is given that the curve and the line do not meet, we have the condition of the discriminant as b square minus 4ac is less than 0. Now here a represents the coefficient of x square, which is 2 in this case. So we have written a is equal to 2, b is the coefficient of x, which is k minus 3, and c is the constant, which is 8 over here. Now let us plug in these values in this formula. So here we get b square becomes k minus 3 the whole square minus 4 times ac becomes 4 times 2 times 8 is less than 0. Now we are going to expand k minus 3 the whole square by using this algebra identity, that is a minus b the whole square expands as a square minus 2ab plus b square. Now in this case a represents k and b is 3. So k minus 3 the whole square expands as k square minus 2 times k times 3 plus 3 square minus 4 times 2 is 8 and 8 times 8 is 64 is less than 0. Further simplifying this, we get k square minus 2 times 3 is 6 and 6 times k gives us minus 6k plus 3 square is 9 minus 64 is less than 0. Now finally we get k square minus 6k plus 9 and minus 64 gives us minus 55 is less than 0. Now here we have to factorize this equation, and for that I'm going to use splitting the middle term, and in this method we have to multiply the coefficient of k square, which is 1 in this case, with the constant, which is negative 55. So 1 times negative 55 gives us negative 55. Now we have to find out two factors of negative 55 in such a way that when you multiply them you should get negative 55, and when you add them or subtract them you should get the middle term, which is negative 6. And the two factors which we have here are negative 11 and positive 5. Because when you multiply them together, you get negative 55. And when you add them together, minus 11 plus 5 gives us minus 6, which is the middle term. So in the next step, we have split this term into two factors. So we get k square minus 11k plus 5k minus 55 is less than 0. Now let us group the terms. We are going to group the first two terms and we are going to group the last two terms. So from the first group we can see that k is a common factor. So we have taken it out, and inside the bracket remains k minus 11. And from the second group we can see that plus 5 is a common factor. So we have taken it out, and inside the bracket remains k minus 11 is less than 0. So now we have two factors of k, that is k plus 5 times k minus 11 is less than 0. Now to find out the values of k where the line and the curve do not intersect, let us make use of the graphing method to find out the values of k. Now here, k square minus 6k minus 55 is going to be a U-shaped curve because the coefficient of k square is positive. So the curve will be having a minimum point. And let us say that these are the values of k over here. Now k plus 5, let us take it as equal to 0. So here the first value of k we get is negative 5. And that would be over here. Let us take it as negative 5. And let us take it as 0. This is the center point. And this side the positive values begin. And the second value is going to be k minus 11 equal to 0. So k will be equal to positive 11. So let us say that it is over here. Now since we are looking for the part of the curve which is less than 0, so we have to consider all the points which are below this line of k. So this is the area which we have to consider. So k square minus 6k minus 55 is less than 0. Represents all the values which are below this line. So in between negative 5 and 11, we will get the values of k where the line and the curve do not intersect or do not meet. So this is our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find questions on trigonometry, differentiation, and binomial expansion and more. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.